Look into my eyes.
Are there more applications specifically for thermal technology?
Indeed, let's say, next to all the applications that we already had with our visual cameras, there are some applications that are unique to thermal. And all of the very important, let's say, detections that we are now capable of doing, is not possible, in fact, or it's very hard to do it with visual cameras, is fire detection. Let me give you some examples of fire detection that we have been using in tunnels to, let's say, give you an idea about the accuracy and the speed of detection. And then you will, let's say, very fast understand that we are doing a lot more now than the detections that we used to do with visual cameras. So let's say I'm going to explain you a little bit what you're seeing here before that we are actually going to go a lot further. We have here a tunnel that has some temporary wiring. And at a certain moment, the tunnel owner was cleaning the tunnel. And the problem was that there was water entering into a connector box. So what you're seeing here is how does a thermal camera, this visual and thermal, is going to respond to this event. So what you're seeing here is that very fast, the moment that you have, let's say, a fire starting, it's about 5 seconds that are necessary to detect the fire. And what you can also appreciate here is it was a very small fire and it was going out very fast. So this is an example, a real example of a fire in a tunnel where other technology, existing technology in tunnels doesn't work because it's too small and it was too fast that it was, let's say, eliminated. Our technology is capable of detecting these very small fires very accurately, very fast. And that means that instead of waiting for, on average, 10 minutes between a starting fire and the detection by, for example, your linear heat in a tunnel, detection technology allows you to detect in less than 15 seconds. So these 10 minutes, or let's say 9 minutes, 45 seconds, you really have a lot more time to take out the fire. And that's extremely important. Let's say if there's one important point about fire detection is that it should be reliable but extremely fast. And that is exactly what we're giving here. Now, for some of the viewers, they will say, well, obviously, let's say the fire that you see here, it's very close to the camera. Imagine it was a little bit further and probably the thermal camera would not see it. Now, I will show you in my next slides the next camera in the tunnel. So the one that was installed before. And what you see here is now the fire will happen here. It's even detected with the camera beforehand. We are looking here at a distance of around 85 meters, something like that. Well, at 85 meters, detecting such a small fire, the only technology that I've seen doing that is thermal technology. So it's extremely strong in this environment and for this particular application. But it doesn't stop with the fire detection. Another feature, and let's say another feature or another advantage of thermal cameras here is that we can look through smoke. So what you'll see here is that although that here you have, let's say, the tunnel filled with smoke, this is exactly the same guy walking around because it's a synchronized video. You don't see anything here, but here you see him perfectly walking as if there is no smoke. Well, next to the fire, it's going to be used by the fire operators to make sure that they know what is exactly happening in the tunnel. Although that you will have a lot of smoke, you can still see exactly where you need to enter to save the people, for example, that got out of their vehicle. So this is one of the main applications that are so specific that only thermal cameras can address it.